button to make sure that we have backups. So let's start. We are going to first, today is going to be all STL, and if we can get to files, we're going to start, we do a little bit of files and then going deeper in files with binary access and so on and so forth. But we're going to start with strings. First of all, does anybody have any question in mind before we want to continue? Any questions? Let me let me set my polling on so I can actually start a poll. So in here. So any questions? Okay, that's good. That's better. Okay, so I can actually get a reply from you and see who's doing what. That's fantastic. All right. And okay, and here I'm going to say answer. Do like that.
Oh, sorry. Actually, I do have a question.
Go ahead. Go ahead, Karen.
Will there be some sort of practice midterm that we'll have access to help us study for the midterm next week?
Practice midterm? I don't think so. I'm gonna give you what the questions are. So what happened? I don't know if it was your class that I asked if you want the questions to be coming out quicker or not. But in one of the classes, we asked that, and 80% of the students said that we want the questions quicker. So what I'm gonna do, I'm gonna give you the questions like a week before the midterm. So you have the
Okay.
questions. You don't need practice. Just practice on the real questions.
Okay, all right.
I
Thank
think
you.
that's going to be easier, right? All right. Okay, so that's that. Any other question? All right. So let's start with strings. So in C++, string class is a part of the standard template library, and it uh, provides a dynamically safe and feature-rich alternative to what C strings are, essentially C style string, the one that, so a null terminated array of characters that we had in C, it completely eliminates all the pitfalls of the manual memory management and uh, leaks and length of the strings and things like that. And it offers lots of tools to simplify working with text. So strings essentially are dynamically resizable, which means they automatically grow or shrink as we need them to do so. Um, this memory management is handled internally, and it reduces the risks of overflow and passing through and exceeding the size of the array and things like that. So it makes essentially working with texts uh, risk free somewhat. It has a rich set of member functions for all the operations that you want to do for with text, like concatenation, searching through a string, do modifications and things like that. So this essentially what a string is. So what we do when we are doing instead when we are using string, essentially what we use, we add uh, the string header file at the top of the thing, and we can literally create strings as we go, so as a single variable. So I can simply say, sorry, my apologies. I keep forgetting to mute my cell phone even when I'm doing online. So let me shut this up. There we go. That's that. Okay, so I can literally say string, say str1, and I can set this to essentially a string. So I can say hello, that's that. So, and I can go see out str1. So essentially what it does, it internally creates a string, a C string inside the string and handles it for me automatically and dynamically to the size of what we have. So you can create a string like this, or you can create a string using the constructor version. So you can say string, say str2, uh, learning C++. Oh no, sorry. I said the constructor way, so that I did it like this. Or you can use the curly brackets if you want to. They're all the same. All right. Or you can use initialization for it. So essentially, you can say something like str3. You can do something like I want, I don't know, 10 asterisks, something like that. So in here, I'm gonna go str1 and str2 and str3. So essentially, I'm going to print all these things out. And obviously, the result would be as we see. So strings are essentially to encapsulate any text that we want to work with in C++. Are we okay with this? All right, perfect. So let's put this one, string construction. All right, so how do we concatenate strings? Concatenating strings are done obviously using the operator overloading, and also at the same time you can use the function append. So as you see over here, I have a string called first name, I put John, last name I put Doe, and then I say full name and I put plus over here. So essentially the first one is overloaded with a C string, this plus is overloaded with string. The outcome of this one will be a temporary string, and that string will be added to the second one. So one string to another, and then it keeps going like that, and you can have the full name inside full name. So you can combine strings, or you can append one to another using the append function, and running it will work as follows. All right. So that's concatenation. You can access and modify characters using the index operator or the at operator. So essentially, the at operator, at function works the same way as index. So I can say string word apple, then I can say word 0. That's going to show A. Then I can set that one to lowercase. If when I output, it's going to output apple. When I put 2, then it's going to actually have a safe, it with at 2, it actually accesses the second one. It's a safe access and checks the bounds, so it won't crash if you actually do something like that. Therefore, running this will work exactly. So, and all these things, it shouldn't be a mystery to you how this thing works. It's simply the index operator that is overloaded for the string. If you were my OOP244 student, we actually implemented all these things in a strings ourselves, if you remember. Problem down to this point? All right. Okay, so now another thing that is important with string is properties. So you can actually, the string has a specific type of properties that you can check to get the state of your string as you're going through it. So if I have a string called sentence, I can see what is its size, I can clear it, I can see if it's empty or not. So all these properties are accessible and we can be checked. You can check if it's what is the size and if it's empty. Obviously, it has much more stuff, but just letting you know, you can uh, go through the specs of the string and look at all the properties. There are many things that you can use. So you can literally run the string as follows. As you see, it tells you what is the length or if it's empty or not. So this is essentially the properties. If you feel I'm going too fast, please let me know and I'm gonna uh, stop. Okay? You can essentially use functions and methods to find substrings out of a string. So something like find. So I can say actually find where is C++ for me and send me the position back. Now, if that position is npos, npos essentially means the it not found. So if POS is that one, it means it didn't find it. So, but if it finds it, it actually sends the position back so you know exactly where in a string is. So you can actually find a substring inside the string like this. So C++ is found at position 15. So this is substrings. Now, another amazing feature of string is that you can do insertion, erasing, and replacement of pieces and parts inside the string. So what happens is this. So, and it does it for you automatically and uh, simply uh, resizes the string like that. So I'm going to say I love C++. I know you all do, so I'm just putting it over here. Then I'm going to insert at position 7 learning. And then I'm going to erase from 2 and 5. So it's going to remove the between 2 and 5. And then I'm going to replace 2 between 2 and 3 with enjoy. So essentially, if I walk through this is what happens. So the sentence over here is I love C++. Then when you insert learning, then the sentence because I love C++. And when you erase positions 2 or 5, then it because I learning C++. And then, oh, the output I put wrong. My apologies. Anyways, removes, yeah, come on. Yeah, removes 5 characters from position 2. And now this one replaces C++. So this is going to be I enjoying C++, something like that. Okay, so yeah, wow, I enjoy learning. Okay, I have to fix it. Some example I wrote. Okay, Anyways, I'll correct that later. Save it. So essentially this is insertion, erasing, and replacement. I'll fix the example later on. So this is essentially what string is. String is essentially a replacement for C strings that we have, and it keeps track of all the changes and things that you do, and um, works pretty nicely. So let's use the string class from now on instead of all the C strings that you have. Then that's pretty helpful. Now, after C++17, but obviously, first of all, any questions now to this point? All right. So after C++17, because if you recall when we implemented string, all the things that we have done over here essentially goes through dynamic memory allocation, and every single thing that is written in here, which is we essentially reallocate the entire thing. So any changes that you do, because this is a string that is created, when you're actually, let me just draw this so I can explain. So when you have a string somewhere, any changes, so this is a string essentially, what how a string is actually implementing your sorry, there you go. So this is how a string encapsulates your string. When you change the string, insert, remove, shorten, do stuff like that, what it does is essentially creating a new string every single time, making the changes from the old one to the new one, and then make the old one accessing this one and wiping the old one up. And this is an extremely expensive thing to do. So to make this thing a bit more efficient, what they have done, they created another class that they call it a string view. So uh, after C++17, it's this string view that is a lightweight, non-owning reference to a sequence of characters. It's in opposite of string. It does not manage the memory for the string that is handling, and therefore um, it is much faster and more efficient for specific type of viewing use cases. So whenever you have a string that you do not want to actually uh, uh, manipulate it and change the content and things like that, it the string view helps you a lot. And why we should use string view? It avoids copying and allocating memory for strings when all you need is to referencing to the existing data. You don't want to change it. You just want to refer to a piece of text and do something with it. Print it, show it. It doesn't have much of manipulation. And it can refer to parts of the string or even raw character arrays using a constant character pointer. So let me just show you how it works. So forgot IO stream. So as you see, when I have over here print string where I want to actually print a string, instead of passing a string over there, I'm going to pass a string view. So what happens is that when print string is actually receiving the string over here, it's going to just point to the data of that string and print it out. Therefore, the values of the string is not passed. You can do all the substring and editing and stuff that you want to do and put it in a string view. So essentially, string view becomes a view inside a string. Therefore, you are not recreating a new string, and it makes your life much simpler and easier. So if you even have a regular C string, you can make sure that it's actually a constant one. You can pass it to a raw string view, and string view will handle that like a string, and you can actually deal with it with low overload in memory management. Are we okay with this? Let me just. There we go. So that's that. Now, what are the key features of string view? It is efficient for passing long strings back and forth without copying. So when you want to, you have it like a text with lots of information in it, and you want to dump it on a screen. If you want to do that, you don't want to pass the string to another function and do it as such. So what you can do, you can simply pass a string view and it becomes much easier. And it provides many of the same methods of string like size, substring, find, and things like that. But the only difference is that all these things are read only. So it you can still search inside a regular C string using a string view using find. You can find a substring of a string inside another string, a C string using string view. So you can do all the little things that string does and apply it to a constant character pointer and makes your life much easier. So essentially, it provides the functionalities of a string inside a regular string. Uh, are we okay with this? Oh, somebody said no. Kian, you said no. Sorry, I didn't see that. Uh, uh, what was the no thingy about so I can explain it? Kian, are you with me?
Sorry, sir, I was just in the car. What did you say? I had to leave and rejoin.
Oh, you had when I ask any problem, you said no. If you have any, do you have any? Is there any are you okay? Everybody said yes. You said no. So I don't know what was that no about. I
Oh
missed
yeah,
that.
for the the string view.
Uh huh.
Yeah, I'm having a little difficulty understanding, kind of like I don't know, just like
No,
generally about it. If you could
let's put
go
it
over
this
it
way.
again.
Let's put it this way. Let's put it this way. So the string has all these functionalities that it does dynamic memory allocation for it, right?
Right.
When you do not want to modify a string, all you want to do is to view inside and see what's inside and do with it in a read-only matter. You use a string view. That makes your program faster. It's as easy as that.
Okay. So when you just do like find or like display it
You can
and not
find, you
really
can dis
append
yeah,
or add to it.
exactly. You can find out
Okay.
what the size, you can see, you can find the substring in it, but you don't want to, you don't find you don't want to find the substring and replace it with something else. You just want to find it.
Okay.
If that's the case, then string view is your friend.
Okay. All right. Thank you.
All right? Okay. So what are the limitations? So string view does not own the data of the original string. And um, so the original string must remain as what it was. and you cannot modify a string through a string view. It is extremely important to understand that. So, um, to let me just open my cheat sheet over here. Where is my cheat sheet? Just a second. My apologies. Just a second. Just a second. I had something created so I can actually have little things displayed over here. Let me just. There we go. So in here, I'm going to have something like this. I'm going to say resources, add, new item, utility. I'm going to say text, and I'm going to call it uh, string versus string view dot md. Okay. So I'll put it over here for you so you can actually see. Okay. So what string is, what string view is. So with regard to ownership, strings owns the data, string view doesn't own the data. Modifiability, uh, the string is mutable, you can change it. String view is not, it's read only. String is dynamic, that has lots of memory overhead, it does resizing and stuff. String view is lower because there's no allocation. And best use case for all the string is that when you want to store or modify text, but with string view, when you only need to do have a read access. Um, Let me just put this thing somewhere handy so I can bring the rest of it up. So are we good with this? Everything's good? All right. So let's close that one. And I added that one to the repository so you can actually take a look at it later on if you want to. So, oh, not here. Let's say that we want to have a function that processes a large string. Instead of passing a string by value or reference, we can use string view to avoid unnecessary copying. Take a look at this. So I want to have a find word. So I want to find one word in. So instead of passing strings over here, I can have two strings, and I pass two string views into in the find word function, and therefore it's going to reuse the values that it has in a big paragraph or text or whatever you have, and therefore all the finding and the properties and things that you're using, you can still use the text, but you are not changing it, therefore it becomes faster. Okay, so all right, so that's that.
For that,
Yes,
could we do something like doing all this work in a string view and in the end, like move the content to a string,
of course you
like to
can.
cut corners?
Yes, yes, yes. But see, the thing is that you can't do all the work in string view. Remember that the work in string view is all constant. You're not changing anything. If you are doing find and stuff like that, yes, you can do it in string view and then put it back in a string. That's very fine. But remember, if you
Okay.
want to do a substring and you want to change something, then you have to use a string. I'm sorry. Remember, it's
Okay.
always read
Thank you.
only. Always read only. Okay?
All right.
So So essentially, I could say like this. So you use string when you need to modify, concatenate, or dynamically build strings. Okay? And the ownership and memory management are required. That's when you use a string. But when do you use a string view? When you are working with read-only data. When you are passing substrings or raw character arrays to functions, that's string views. Or you want to avoid uh, the performance overhead of copying strings when you only want to do uh, uh, find and size and things like that. Okay, so I can just say like in an easier way to say, I can say that a string is perfect for managing and modifying a text in C++, and it provides dynamic memory allocation with rich functionality for you. A string view is a fast and efficient way to refer to strings without copying, and it's ideal for read-only access and passing data to functions without overhead. Are we good with this? All right. Oh, Vishal, you said no.
Yes, actually, I was going to ask you, like, how about overwriting a string view,
Pardon me?
assigning it to another? How about overwriting a string view,
How do we
like assigning
overwrite a
it?
string view?
Yes, like
You don't.
assigning a different string.
No, no, no. If you want to do overwrite, that string view is not your friend. You are doing modification.
Yeah, would that
Str-
work?
String, no, it won't. String view is just a view. Okay, let's put it this way. Let me just show it for you so you see when you say overwrite, what does it mean? Whoops, I put the wrong button. So this is a string. When you copy this string, pass this string as a string view, this is your string view, which means nothing new is created. It's just pointing to the data. But you have to remember that this is read only. You follow what I'm saying? So you have access to the data of the string. So please remember that this is a string and this is a string view. With string view, you are not creating a new thing. You are just using the data of a string or a C string even, or what you may call it, a regular or C array with read-only functionalities of string. So if I have another string, I hate it when it changes the color of what you had before. There we go. Okay, so when you have another string that points to another piece of data, if you want to use that string view with a new one, all it does is that it is going to point to the new one and the old connection will be lost. So you are not overwriting the string view, you're just viewing another string. Vishal, does that make sense?
Yes,
All right,
yes, it
perfect.
does.
Thank you. Okay, so that's that. All right. So that's about strings. And please go read what we have for the string section of the thing. And if there is anything missing over there, please come and talk to me and come back with questions. And that is that. So let me get out of here. I don't need these. Does anyone need a break before we continue with containers? Anybody needs a break? Okay, I have a few people. Okay, you'll see 25% of people are 31%. So, okay, uh, say 10 minutes break. We're going to be back at 2:30 to continue with the rest of the lecture. I'm going to pause the recording. Please remind me to continue the recording. I'll see you in 10 minutes. All right. Victoria, Sola, Peterson, and Parth, where are you? We want to start.
You're good.
All right. Okay, so let's continue. We're going to talk about containers now. So, in C++, uh, containers that are implemented in standard template library, they provide an extremely powerful and flexible way to uh, manage collections of data. Now, these collections of data are implemented in many different ways, and we'll see them too. And uh, to be able to access the elements of data in these collections in STL, they created something they called an iterator. Uh, that iterators kind of work like uh, uh, classes that replace kind of pointer to elements, and they point to the elements of these containers. So along with these iterators that allow kind of a seamless way to traverse and manipulate these data, these tools, the containers and iterators, make the data management much easier and much more efficient. So what the containers are, these are classes that are designed to store and organize. Alan, you had a question? No? No? No. Oh, so these classes are designed to store and organize these collections of data in memory, and they come with different types, each one uh, um, with different types of algorithms and designs, and each one is optimized for a specific operation. So like some of them are quicker to access information, but they are slower in insertion and deletion. Some of them are quicker in insertion and deletion, but do not access as quickly, or ordering and things like that. So, what are the benefits of using these containers? First of all, they add to simplicity. You don't need to implement different types of uh, data structures for containers to do things. They're already made ready for you. These are containers that handle memory management automatically. They are extremely flexible. You can choose the right container for the specific need that you have. For example, you want to have fast access, or you want to have easy insertion, or you want to have uh, uh, a container to order things for you automatically. And the most important feature benefit of using these containers is consistency. All the containers work with iterators. So those iterators that point to the elements of the containers, it works for all of them. They work exactly the same way for all of the containers. And it makes an easy way to loop through the element and traverse through the elements easily. And that's the reason we use containers. Do we have an understanding of a ballpark of what containers for? Oh, let me see. My poll is gone. So do we have a preliminary understanding of what containers are used for? Kian, you said no. Tell me.
Could you go over it one more time?
Okay. So we need to use data inside a massive amount of data in computer science. There's no question, but that's the purpose of computer programming. Because of that, we have things like arrays and things like that. But these arrays are very difficult to manage. You can put series of stuff in an array, but to order it, it's difficult. To resize it is difficult. To find the specific thing in an array is difficult. To insert an element halfway through an array and shift everything to right is difficult. To remove an element from an array is difficult. To reorder it is difficult. Because of this, they created this intelligent arrays. We call them containers. And each container treats this array in a specific way. One of them is fast to access the elements, but because of this, it is not as fast for insertion and deletion. So if you want to add something in the middle of the array, it's not as fast. But another one is extremely fast to insert something in the middle of an array. It doesn't use much of memory, but it's because of that, it's much more difficult to access each element quickly. So based on what we want to use with these intelligent arrays, with these specifically designed arrays, we use a specific type of them. Does that make sense, Kian?
So containers are basically like remade special types of arrays that we
Exactly.
can use depending on what we need.
Exactly. They are specific. It's different types of array designed for something. So if you want a fast array to access something, you use one of them. If you want an array, so you want to insert stuff halfway through it or something to the end at the beginning, you use one of them. And I'm going to tell you one by one which one is what. Okay?
Okay. All
All
right.
right.
Thank you.
Okay, no problem. Anyone else? Any question? All right. So, uh, let's see the most commonly used containers in the STL and standard template library. Look at their strengths and weaknesses and real world scenarios in which we are going to work with it. The most common uh, uh, container that is used is called a vector. So a vector is essentially a dynamic array. It stores the elements in a contiguous memory. So essentially, vectors are literally dynamic arrays. Okay, so accessing the elements because of this fact is quick because they are all in an array and ordered back to back in memory in one continuous piece of memory. If you want the 50th one, it can use an address and just poof address to access to it very quickly. Okay, the size of the vector grows automatically when elements are added, so automatically adds it. So the benefits of vectors are fast random access. When I say random access, it means you can quickly access elements using the index of the array. You can dynamically resize it as you are going through it. It is extremely efficient for sequential data and works great when data is added or removed from the end only. Okay? shortcomings of vectors is that it's slow in insertion and deletion in the middle. All the subsequent elements must be shifted to right and left if you want to do that. And resizing overhead is very high. It's it doubles the it doubles the capacity when resize it, and is very costly memory management. So it's essentially the dynamic memory allocation that we do manually ourselves. So let me give you an example on how vectors work. So vectors are templates, like this is a standard template library. So as we created the dynamic array when we were teaching templates, vectors work that way. So I can actually create a vector of integers and call it numbers and set it to 10, 20, 30. So essentially it creates a vector of three numbers. I can say push back, so I add something to the back, and push back again. So using the pushback method, and remember these methods are commonly used between all the containers. So they name the methods the same way because of inheritance and the interfaces that they all come from. They all come from containers. So if I say pushback 40, I'm adding at one at the end. If I say pushback 50, I'm adding another one. You can access the members of the of a vector using index. So you can modify exactly like an index and access the value of the index. You can insert values inside a vector. But again, remember, these are expensive. You can do it, but they're expensive. So begin over here essentially means the very beginning of uh, uh, the vector. So I can say insert 15 at index 2, or erase the second element the of the vector. So begin in all containers, returns an iterator to the beginning of the container. So essentially when I say insert numbers begin, it means insert from the beginning to further. Insert erase from the beginning one further. So essentially that becomes the second element. And using the range-based loop, I can go through every single member and show the value. So essentially, when I run this program, you'll see that the values are inserted and removed exactly as I described in the program. So that's it. So this is a vector. Questions about vector? All right. Next one. So remember, the use case for vectors is when you want fast access and work mostly to the and work mostly at the end of the collection. When you want to add something, you want to add it to the end of the collection. Remember that. So and essentially, you have to remember when you want to use arrays and you don't know what to use. Vector is your friend. That's it. Okay. Next one is list. List is a doubly linked list. A doubly linked list is a linked list that each element points to the next one and the previous one. So essentially, it's something like this. So with a linked list, it's like this. This knows where is this one, that one, this one, that one, this one, this one, and it goes over here, and they all go backwards too. So essentially, each one knows where is the previous one. Obviously, having something like this means from the beginning, so this is the beginning where everything begins, and this is the end where everything ends. So let's do it like this. So in here, I'm going to say that's the beginning, which means it points to nowhere. And this is the end where it points to nowhere at the end. So what happens is this. With a doubly linked list, as you see, the elements of the linked list are not in order in memory. Each element knows where the next element is. How? Get the data structure course to see how. But that's how it is. So from the beginning, I can go to next, 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 and I can go right to the end and I come back. The good thing is that if you want to insert something in the middle, it's very simple. So if I want to enter something, if I want to enter something in the middle of the array, of the linked list, of the list, I don't need to worry about what goes where. All I need to do is to make sure this knows which one is the previous and which one is the next, and so for the other one. So the other one needs to get updated. And as you see, when you do like this, you simply sever the other uh, links, and you can add a node right in the middle of the linked list without moving anything anywhere. Even removing is easy. If you want to remove a linked list from somewhere, all you need to do is to say, I want this one to point to that one, I want that one to point back to this one, and you simply remove this. And as you see, the element is removed without all the elements moving anywhere. So it is pretty complicated, as you see. Insertion and extraction is not as easy if you want to write it yourself, but it's already done for you in a container. We call it list. Okay? So how does the list work? It's a doubly linked list. Each element points to the previous and next element, and it's amazing for frequent insertion and deletions anywhere in a collection. The benefits for it is fast insertion and removal. The operations do not require shifting the elements back and forth. It is efficient when you want to modify. It's ideal for data structures that requires frequent rearrangement of elements. The shortcomings, it doesn't have random access. If you want the 10th element, you have to start from the beginning and keep counting until you get to the 10th one. So it's very slow when it comes to accessing the elements. And it has a very high memory overhead because each element requires extra memory to point to the next and previous one. Each element has lots of bells and whistles to be able to access the other ones. In an array, an element is an element of that type. It doesn't need anything to point to the previous and next. But if you want to have the list of information, each element of your list needs additional pointers to previous and next. How it works is as follows. So as you see, it works exactly like with creation. It works exactly like a vector. So I'm creating a list of numbers, and I can push front, which means I go to the beginning. I can add to the beginning. I can push back, add to the end. I can use what we call an iterator. So essentially, I'm going to say auto IT. That's the iterator that I was talking about. So it actually points to the beginning of the what should we call it? The list. Now I can say advance the iterator second forward. So essentially, it moves the iterator to the next. Okay, and then I can say insert 15 at right after the right before the third element, and I can say remove 20. So essentially, it removes all occurrences of the value 20 from the list. Then I can say, yeah, so, and, but going through them is the same thing. So as you see, it is very useful to insert values inside uh, a list and remove and do lots of manipulation. But you can actually use the index in here to access if you want something out of it. But uh, vectors, you can use the index operator to access the values, but it's extremely slow if you do so. So this is how the lists work. Questions about lists? Any questions? All right. Now that we've talked about lists, we're going to talk about DQ. So the next thing we want to talk about over here is the use case when so uh, it's a it's called a double-ended queue that it allows fast insertion and removal for both ends. Internally, it stores the elements in multiple memory blocks rather than one contiguous array. So it's like having several arrays used to keep the information in the memory. The benefits for it is that it is efficient at both ends for fast insertion and removal, and it supports random access for as an index to access the elements of the DQ. The shortcomings is that it has higher memory usage than vector because it has segments of memory and is not as fast as vector for random access. A DQ is like this. So as you see now, I have a DQ. Again, I have push front and push back. I can pop something from front, which means taking something out, and put some, you can pop back too if you want to. You can access it with the index element, and you can go through it exactly, go through the elements of DQ using uh, uh, what we call, what do we call this thing? Using uh, what was the name of this for loop? I forgot. Went out of my mind. Um,
Range based.
yeah, range-based for loops. Thank you. So you can use a range-based for loop to go through it. What I want you to note over here is that uh, they are all used the same way because they all come from the same parent container. They're all used the same way, but you need to know which one is used for what reason. I'm going to give you an overall view of all the things that they are so you can actually see. So this one is a DQ. Any questions about DQ? All right. Now the other one that is very useful is a set. A set stores unique elements in a sorted order. So it automatically removes duplications and organizes the data in an ascending order. The benefits for it is it ensures no duplications when they are stored, and it always keeps the elements sorted at all times. It has fast lookups. You can check to see if an element exists in it or not. So it's very efficient to see if something is in the set or not. It doesn't have any random access element by index, and it's slower for sequential access compared to vector. And this is how it is. So I can create a set of numbers like that. It's going to automatically get sorted. I can insert values in it. I can find certain values in it to see if it's there or not. I can go through them one by one and see what they are. So you run this program, you will see that everything that is there is automatically sorted by the values that you put in it. It's very useful to keep the values in order and do search within your set to see if you have something duplicated or not. Are we okay? Do we understand what sets are used for? Perfect. Whew, next one. You have 15 minutes. I hope I didn't fry anybody's brain yet. Next one is what we call in data structures as a dictionary. So what happens is that this thing is called a map. So a map is essentially a collection of key value pairs. Each key is unique and all the keys are sorted. What do we use this for? To do fast lookups by key. Retrieve elements using key values in a logarithmic time, which is very fast, and it automatically sorts all the keys and the data organized. What is it not good for? It has no random access. It literally retrieves the values using keys with quick searches, and it requires additional memory for keys and values. So, for example, if I want to keep series of phone numbers in, let me just show you. So I want to, this is, let me just, so I use a map for a string and an integer that is mapped to those strings. So essentially, and I call it phone book. So I'm going to say phone book, Alice is 1234, Bob is 5567. And then if I want to find out what is the phone number for Bob, I'm going to say phone book, and in an index, I'll put the key. Oh, sorry, Alice, as a key, I'm going to put the name Alice. It's going to go through the dictionary, find out what is the value for Alice, and take it out. And it's extremely fast through it. So you can simply use a range based loop to go through every single key and every single value that you have and take the values out through the map. It's very useful to, as I said, hold dictionary values in data structures. Essentially, you have key values, and you have keys, and you have values stored for the keys, and you can insert them in a map and access them one by one. Are we okay understanding what maps are good for? Oh yeah, so let me just go through it. Here we go. Now, let's understand iterators and see what are iterators. Iterators are essentially objects that point to elements in a container. All these elements that we talked about, you can use iterators to traverse through a container just like pointers. So you're essentially abstracting away the container's implementation by using iterators pointing to their elements. Um, for example, basic iteration, if you want to just do go through the values of a vector using an iterator, this is how it works. You're essentially you're saying for, and you create each container. So essentially, if I have a container, whatever container you have, so whatever container you have, when I say container, you know what I mean. A container means map, set, DQ, list, vector, whatever you have. Container for the type that you have, then you create iterator for it. And this is iterator name. Okay? And this creates an iterator for a container of that type. So vector of type employee iterator IT, which means this iterator only points. So let's vector employee iterator employee iterator. So essentially EI over here is an iterator to any vector of employees. It can point to the elements of those vectors. Do we understand how iterators are made? All right. So now, because of that, I'm going to create a for loop, and I'm going to say I want an iterator of the vector, and it starts at the beginning because we know begin returns the iterator for the beginning that points to the beginning of the container, and end returns an iterator just after the last one. So essentially, I'm going to say start from the beginning, go up to the point that you're not hitting the end, and one by one add. And as you see, plus plus is overloaded for the iterator to actually advance the iterator to the next element. And each container knows how to advance to the next one. So don't worry about it if you have a list and list all the nodes are all the elements are all over the memory, or you have a map where you are using uh, keys and paired keys to get the values out of it. When you do the point to the iterator to the beginning of the container using plus plus, you can simply go to the next in sequence. And asterisk is overloaded. The target of is overloaded to extract the target of the iterator element in the container, whatever that is. So when you say asterisk iterator, it's essentially target of iterator. Works exactly like pointers, therefore you can go through them one by one as if you are going through the elements using a pointer. Are we okay understanding the iterators? Iterators? Come on, Raj, are you with us? I don't see your response. There we go. All right. Now, reverse iteration. How do I go backwards? Okay, so let me just write over here. And how do I do reverse iteration? If I want to go, if I want to reverse, how do I do it? So if you go R begin, it means go to the end. R end, it means go to the beginning. Therefore, when you plus plus the iterator, it goes backwards. So this is called the reverse iterator. So R begin goes to the end, iterator to the end, R end one before the beginning. So essentially R begin points to 30, R end points one before 10. Do we understand this? All right, so if I run this, it's going to go backwards. I have 9 more minutes. Let's see if I can finish this. So reverse iterators.cpp. All right. So if you want to have constant access, so let's say you pass a vector as or a set or whatever you want as a constant reference to a function, and you want to access the elements using an iterator. If you want to do that, then what you need to do is to actually create a constant iterator to the elements of the container, and that's using const iterator. So if you create a const iterator out of an element, it works the exact same way. So you can go begin, end, and that becomes a constant. It works with the reverse one too. So if you want to do r begin and r end, it works the exact same way. But this iterator has a constant read-only access to it. Therefore, uh, it's not going to go. I just received something over here. Okay, that was strange. I don't know what happened over here. Just a second, something happened in my computer and suddenly Bing came up with something. Anyways, all right. Where was I? There we go. And that's that. That's the constant iterator. Are we okay with constant iterators? All right. So now going through the containers, the points that we want to actually consider when we want to understand what type of container we should use for which scenario. What do I call it? Containers.md. So if you are in summary to see what containers are which container is good for what, vectors, fast access and sequential data you should avoid when frequent insertion or removers in the middle are happening. List, frequent insertion or removals, random access is needed. You have to avoid it if you want random access lists are not for you. DQ is insert and remove at both ends. It's memory and you should avoid it when memory efficiency is critical. It uses lots of memory. Each node has a pointer back and forth. Set is for unique information and are sorted, and duplicates and you should avoid it if duplicates are required. And maps are used for key and value storages with fast lookups, and you should avoid it when data that you have don't have keys. Uh, it's not a dictionary type of thing. Are we okay with understanding containers and what we are using them for? All right. All right. So Solar Parth, Mohammed, Mike. Yes. We good? Peterson. Yes. What's up?
We have some questions on the chat.
Or,
Um, if we initialize an empty container, do
or
we set the default value to null pointer or
Peterson, you're cutting off. It's
do
difficult
we
to understand. Can you type it, please? Because your audio gets off and on.
okay, right, like so
I'm looking at the chat. If we initialize an empty container, do we set the default value to null point? No, you don't need to do anything like that. Containers take care of everything themselves. You don't need to set anything to null pointer of any kind. Unless you're having a container of pointers and you want to have them null, but it will be null anyway. So don't worry about it. Oh, okay, so that was the question. All right. Any other question, anyone? We went right up to algorithms. I was hoping to get to files, but I couldn't even get to algorithms. But we'll talk about it the next day. Don't, no worries. So if we are okay, I think we're gonna call it a day, and uh, that's that. Questions, anyone? Suggestions? Objections? All right. Have yourself a beautiful day, and I'll see you on Friday, I presume. Bye, everyone.